office hour. This is the office hour for Oregon State University, PDC Pro, repeat myself, summer 2025, June 23rd to December 14th, 2025 cohort. Okay, this is call number 5, and the next lesson is lesson 5, water survey, watershed map, site water flow, due next Monday, September 1st at 9 a.m. Pacific. Remember that after this, we don't have another call until September 29th. So lesson 6 is due the following Monday on October 6th. So on September 22nd, you will see the lesson material drop for lesson 6, and then our call will be the following Monday on the 29th. Okay, this is going to be a pre-tutorial reading with no Q&A because we had a internet connection issue this morning and lost our recording and our call. So unfortunately, there will be no students showing up for questions today. So I'm just going to go through a tutorial of the template for lesson 5. Okay, so I'm going to just line these up, get a share ready. Here we go. This is actually, I'm using the wrong template, so it's actually a good thing that this didn't work out right now. So I'm going into, okay. I'm not sure why I have the wrong one, but let's see what we got here. Because a number of things have changed, I want to make sure I've got the right one here. Base map, past that. Just giving it a minute to let things load here. Okay, we've done sector compass. Okay. Here we go. Water survey. Okay, so we've got a screen share going here. Once again. There we go. Okay, so we're going to share the template. Okie dokie. All right, here we go. Okay, so just checking in on the template for lesson 5. This lesson's grades are distributed across the water survey, so that's my 3 points. Watershed map, which is collectively 10 points, and site water flow analysis 8 points for a total of 21 points. There are also 1 to 3 bonus points available for the site water flow extra credit assignment. So that is optional for you to do. Most students that are on a rural or sometimes even a suburban site, often larger properties, will find the additional assignment more useful to them because they've got kind of more dynamic flows, more inputs of water to their site. However, if you're on an urban site, by all means, go ahead and do it. It's a good exercise just getting an understanding of the whole landscape around your site and where water might come from any different direction across your property boundary. All right, and another note, this is also one of the largest assignments in the course. A lot of students do find it quite challenging, and there's a lot to it. So take your time. If you need to, as ever, if you need to submit a little bit late, that's perfectly fine. I do like to get a heads up, but it's fine if you're submitting late. There's no point penalty for that or anything. Okay, so starting with the water survey, you'll see it's pretty straightforward. Follow the instructions. This is a good place to use really clear graphics because a lot of you will be pulling, possibly news sources or, screenshots from news clips or graphs, things that are coming from different sources. To make sure that they're really clear, err on the side of a few well-represented ones rather than a whole bunch of, ones that are really shrunken down, really difficult to read at a smaller resolution. A lot of your information is going to be coming from municipal or regional resources. So either from your city or from your county, a little bit of both. This is a good time to get on the phone and actually talk to people, get information about where your drinking water is coming from. Not just, obviously not just from the tap, from your city water, but where is that water coming from? Is it, do you have a desal plant, which is, fairly uncommon? Is it coming from the Colorado River? Is it coming from, is there a reservoir system? How is that filled? Like, really get into where is that water coming from that is, coming out of your tap. You'll definitely want to be sure to be citing your sources here. Just, either in here, or if you're putting them into an appendix, just keep those organized. Get lots of details. If you're on a rural property and you're on a well, if you haven't done already, good time to get a well check, water test. You should be doing that at least every year. If not a bad idea to have it like once at the end of the wet season, once at the end of the dry season, if that's kind of seasonally appropriate to you. Any history, if there's a history of like when that well was dug, how deep it is, any history of water, ingress of seawater if you're close to the coast, anything like that. Ag water ingress is another issue sometimes. All of that is useful here. And then similarly for your wastewater processing, this is going to be where you might want to call up the wastewater plant, see if you can book a tour. A lot of students have actually gone on live, get out there, really talk to people, walk through the water treatment plant. Often they do public tours. Where is that water draining into? Is it draining into a local creek system? What does that creek look like? Any of that information is really useful and interesting. If you want to split this across 2 slides, you're welcome to. Keep in mind, it's not a huge amount of your points, but it is really useful information and a good thing to be aware of, especially if you're in either more like a volatile or natural disaster prone area. Good to know where that water is coming from, so that if there happened to be a natural disaster, you want to know how much risk you might be facing, either from water contamination or water not being available, all of those aspects. So. Okay, and then the second slide of the water survey, you're going to look at rainfall and then your roofing materials. So these are important for calculating your rainwater catchment off of your buildings. Rainfall, not just your annual average. You're going to want to look for like 100-year histories, any major flooding events, what the patterns look like. California, for instance, has decadal oscillation, where we have a lot of really dry years and a lot of drought, and then suddenly there's a few wet years. And what are those patterns looking like, so you can start to design your site with those patterns in mind, like stocking up on extra water storage, so that in a rainy year you're going to be able to spread that out into some of the dry years, and vice versa, planning for drought so that you don't have a whole bunch of water loving plants that you've planned around kind of more higher rainfall years, wetter years. Okay. Impact of major precipitation events. This is usually going to be either, like monsoon, really, really heavy rainfalls. Atmospheric rivers are another issue we're dealing with, of course. And then any photos and images and stuff. And again, feel free to split these slides. Just make them really clear. Use your sources and make it really clear what your images are of. So, okay. And then your watershed maps. All right. This is one that I often find that students skip or kind of misunderstand. This slide in particular. So this is the watershed practice sheet. This sheet needs to stay in your presentation. It's not intended to be a topography of your site or to be replaced with a topography of your site. We want all students to be doing the same practice sheet so that we can confirm that you know how to read a topographic map, how to draw a watershed boundary. So you're going to be using these little icons on the side. Use your little red triangles for your high points. I have to keep my cursor off the screen so that I don't give it away, because I instinctively tend to drag them on different points. The design site is right here. It's in a yellow triangle. So what you want to do is use the red, mark your high points, and then use the red dashed line to mark out your watershed boundary, and then fill that in with the watershed basin. Your water flow lines are going to come off of the watershed boundary, or basically showing where water is going to be flowing away from the high points. Use, like in this map, 5 or 6 is usually plenty to show. If you want to add a little bit more, get a little more detail, that's usually sufficient to show me that you know what you're looking at and where that you can see where water is going to flow in and off of this landscape. Okay. And this slide is worth 1 point. So there we do have a like a slide key so that we can see that everybody's basically drawing essentially the same thing, interpreting it roughly the same way based on the tutorials. Okay, and then you're going to get into analyzing your own site's watershed. Many of you often get lucky and you can find clearly defined watershed maps for especially for your macro watershed catchment. So you might live in a well-defined watershed basin watershed that's already mapped out. There's different diagrams that show. So make sure that if you're using those kind of pre-mapped sites, that you're still marking out things like what is the watershed boundary, the watershed basin, water flow lines, and where your design site is. Like, don't just drop somebody else's map in here and be like, oh, it's all here. Make sure that these points are covered, because I will be looking for them and will be marking for them. You can add notes here. That might be, I can't even think of what people have put for notes here. But if there's anything that you want to remark on, that this is a really big watershed, and maybe it doesn't, if you'd like to find something a little bit small. I don't know. If you need to make any notes, use that little box there. I'm kind of blanking on what ideas to put stuff in there. Then you've got your information bar, which this is all just copy and paste by this point. Make sure you've got an accurate scale and your compass rose, as always, because we're into doing maps now. Okay, and then your micro watershed catchment is going to be the localized watershed. So this may or may not be as well defined. Often isn't as well defined as your macro watershed. Do not just take a zoomed in snapshot of your macro watershed. This is the watershed that influences your immediate site's water flow. So it's the area that can actually contribute runoff water to the site. As the instructions say, you can add another page if you want to show it at a few different scales. Like sometimes there's kind of a meso watershed. Sometimes micro watersheds are really built more. They're built. They're more. This will happen in urban landscapes where they're defined kind of by storm drainage or different barriers, construction, things like that. Make sure that you label your property boundary and then show where that water is coming from. And still delineate the watershed boundary, the watershed basin, what the flow lines are on and off the property. And if you can, include contour lines. They may not be available at this scale, and that's fine. Often if they're available at a small scale, some of them you can find they're labeled like 1 to 3 feet. They're probably not accurate, or they're going to be a rough guesstimate at best. So not really worth trusting anyway, unless you've got really, really good data and you're really, bang up on your GIS mapping stuff. So if you're having any troubles with this, don't hesitate to reach out. There are some good tutorials on how to delineate this. You're really just trying to capture where the water's coming from that's going to influence your site. Okay. Just going to see if I had any notes. Site Waterflow. No. Yeah, these can both be a little bit subjective. You might need to make some judgment calls. Again, feel free to reach out if you're unsure. But for the most part, like for the macro watershed, you're going to be looking at the largest river system of which which includes your site. And then for this one, this is going to be the watershed that actually can potentially impact your site where you are. So. Okay. And then site water flow analysis. Okay. All right. So this is where you're going to get your image of your site. So your base map, draw over it with the freeform or line shapes and insert arrows to represent the water flow. This is showing where water is coming onto your site, where it's leaving. You may not actually see this water coming or going. It may be a subsurface flow. So especially if you've got gravelly soils, it may be soaking down and coming through. But basically, is there an opportunity? Like, are you down a hill from another person's property? There's going to be potential for water flow that way. If you're above, if you're top of the ridge, all that water is going to be flowing off. So just show which way water has the potential to be flowing on or off on the property. And then you've got all of these options for coloring different roof areas. I'm not 100%. You're really welcome to take some artistic license here. This can get very complicated, especially because, I mean, one is housing with roof lines can get really complex in urban sites when you've got a small map like this. I'm fine if you pick one color for impermeable surfaces and then just number them, and one color for roof area and just number them, and then make clear boundaries between each of them if they're adjacent. But you can really reduce the number of colors that you use in your legend, and then, conversely, your the amount of space that your legend takes up. So that gives you a little bit more space. And then you can use, here's your water flow, downspout, wet areas, erosion risks, ponds, anything. So you can use these icons. Just delete them. Please do delete them if you're not using them. If they're in your legend and you're not using them on your map, then I usually end up taking off, half a point or a point for that, because if you've got it on your legend, it really needs to be on your map. And that's just it's an important mapping convention to get used to following if you're not already accustomed to doing that. So just a note, because we are teaching you to build proper maps that will be, readable by a client and can be used, for instance, by a landscape designer or landscape architect to actually affect design on the ground or implemented design. So you want to make sure that you're following, you're following these conventions and sticking to the rules of digital design for this. So, okay, digital, or if you're hand drawing, I don't know if I have any students yet in this group that are hand drawing, but yeah, regardless. So, okay. Here you're going to actually do your calculations. So here you want to drop in your chart of precipitation by month. So you've got those numbers. Pick a unit, pick a measurement system and stick with it. Either you're doing metric or imperial. Don't bother with trying to include both. Just pick one and delete the ones that don't apply to your, to your system, your location. And then just follow through with these calculations, get the numbers in, double check them, check kind of intuitively, like, do these make sense? And you may be surprised for small roof areas and like a certain amount of rainfall, you're actually catching quite a lot of water. And so a lot of students do get surprised here to see how much water they're actually collecting. I will be checking, double checking the calculations, but make sure that you're converting, if necessary, inches into feet, and your units are following through. So if you've got any questions, again, feel free to reach out. It's just a little bit of math is going to be required. For this one, your 100-year, 24-hour rainfall event in either feet or millimeters, if data is available, it's not always. If it's not, it's optional to do. Sometimes you can find it through news sources or for a location that's nearby. So say if you're in the San Fernando Valley, maybe there's data for Los Angeles, or, similarly, like if you're in Spain, if you can find something for Barcelona, that may not geographically, depending which side of a mountain range, for instance, that may not apply. But if you think that like geographically it's not too far-fetched, go ahead and use that just to have the practice of going through those calculations and seeing sometimes there's an incredible difference based on like a huge rainfall event that's not frequent, but may become more and more frequent with climate change. So it's a good thing to be able to plan for in terms of risk management, water storage potentially, so on. Okay. Okay, so here's your roof and surface calculations. Now, this is what I was meaning. You can have these all one color and just number them. I'm fine with that. The other thing you can do is if you've got roof areas that are different materials, you could use one color for each material. That would be helpful. So whether it's asphalt shingle, metal roofing, not many with cedar shake, so on, just put that material in there. Excuse me. And then just, follow through the chart area. Again, pick your units and stick with one unit. So, okay. And make sure that here you're not doing feet or centimeters. This is feet or millimeters so that it converts into liters or gallons, respectively. Note that there is a conversion factor here that you may need to use. Okay. All right. And then permeable surfaces, this might be woodland, grassland, so on like that. Okay. And then if you're not sure how permeable your surface is, like how easily water is going to percolate through it, you can go to this rainwater harvest table. And that's going to give you some different ideas. So different materials, how much water is likely to flow through, different types of soil. You've got lots and lots of options. It doesn't matter too much if you choose it exactly right. I mean, look at these. These are ranges 0.2 to 0.4, 0.1 to 0.25. Like there's plenty of overlap. Pick something that's, that makes intuitive sense to you, and that's fine. Okay. And then your extra credit site water flow. So this is where you're looking at the amount of land draining into your site. So your site water flow is just the water that's within your property boundary. Your site water flow goes back to that micro watershed of like how much water could potentially impact this design site. So that's what you want to be looking at. So how much water could potentially flow onto it. So you want to make sure that you're not taking into account any areas where water might be running off, but just where it's running on. And then just do those same calculations. It's just a really good exercise for getting an idea of, how water's moving across the landscape with your site as a part of it. Okay. And then SWOT analysis, which you guys are all doing a great job on. Nothing new there. So this is looking through the lens of your water analysis. What did you learn about water in this assignment or these assignments? Okay. And then what have you learned about your site through this lesson? This should be lesson here. There. Okay. And then your goals and tasks and any questions. And that's it. So that's going to be your last lesson that's due before your break. A really good thing if you're not having to spend a whole bunch of time catching up. So besides actually taking a break and taking a rest, step away from this for a while if you need to, you could go into your soil map and tests and start doing the physical stuff of getting your soil samples. So there's going to be 3 soil samples here. Which, it's all just follow the instructions, get the pictures and stuff. But sometimes it's good to do that a couple of times to get a good feel for it before you're actually taking the pictures and doing all the analyses and stuff. So I do recommend that students, if you're caught up at lesson, to the end of lesson 5, go ahead and go in and move a bit forward into lesson 6, because it'll give you a bit of a head start after the break. It'll be a little bit easier to get back into. Because the end of the course comes up fast, and then you're into your conceptual design, all your detailed design stuff, and you don't want to be behind when you get to that point. All right, because this is just a recorded session, I'm going to turn my sharing off. Okay, because this is just a recorded session and I can't do Q&A on the call, feel free to send me questions through email, through Canvas, or in that other app, the WhatsApp group. If you're not in it, it's a good place to be. It's really easy to shoot me quick questions and I can answer them when I'm on the road, or through Canvas, I have to log into, get my computer open, log into PACE, log into the course, get to my inbox, and then read them. With WhatsApp, you can drop me a question, you can send me audio, you can send me photos, and I can usually answer your questions really quickly, and I can send like little audio feedback. So, okay. Hope everyone's doing well, and look forward to questions coming in and your assignments coming in on whatever day that is, September 1st. All right. Okay. Have a good day, guys. Bye.